Let us discuss about colligative properties. Colligative properties. What are colligative properties? We can analyze in two ways. What are colligative properties and define colligative property. That is, what is colligative property? What are colligative property means we have elevation of boiling point, depression of freezing point, increase of osmotic pressure, relative lowering of vapor pressure. We will discuss one by one all these colligative properties. So, what is elevation of boiling point? It is represented as delta TB, elevation of boiling point, and this is depression of freezing point, and this is the increase of osmotic pressure. Then this is relative lowering of vapor pressure. So originally the vapor pressure of the solvent is indicated as P naught. There will be a lowering of vapor pressure, okay, by adding some salt, so it becomes solution. So this is vapor pressure of the solution. So there is a lowering of vapor pressure. And what is the ratio to the, that is this lowering of vapor pressure to the original vapor pressure P naught? That is called relative lowering of vapor pressure. So we will discuss this one by one. Now let us see what is colligative property. Colligative property, let me give an example or an explanation. Based on that we will try to explain this, define this. Now let me have a glass of water or a beaker of water. So this water is pure. It boils at 100 degrees centigrade. But when we add some salt in that, what happens? Now becomes salt solution, salt. So when you check after adding the salt or some solute, there will be an increase in the boiling point. It won't boil at 100 degree. Instead, it boils at 100.04 degree or 5 degree. It will be only marginal. You cannot expect elevation of boiling means 100 to 200, not like that. So marginal increase in the boiling point. Or you can say 100.5. Okay, 100.5. So let us imagine. Let me take 100.5 degree Celsius. Now, what is the change in temperature? That is boiling point, delta TB, the final boiling point. This is TB, boiling point of the solution, minus boiling point of water in its pure state as solvent. So you can put 100 degree minus, that is 100.5 degree, 100.5 degree minus 100 degree Celsius. So that gives 0.5 degrees Celsius. Okay. So if you want to convert this into Kelvin, it will be retained as, that is 0.5 Kelvin only. You cannot add 273 to the difference. You can add here. For instance, let me declare delta TB is equal to TB minus T naught B. So probably that is you want to convert this. So 200, 373 because you have to add 273, 100 plus 273. So 373.5. What about this one, pure one? That is 273. Sorry, 373. 100 plus 273, 373. So the difference is this is Kelvin, this is also Kelvin. So it's after all 0.5 Kelvin only. I hope now you should understand the delta TB in Kelvin as well as in degree Celsius. Both are same. Okay. So you should not add 273 here. You can add here and finally they are cancel and you have got 0.5. So 0.5 Kelvin. So this is called elevation of boiling point. Why this has happened? So it means the presence of solute in a solution disturbs the physical properties. What are physical properties? Boiling point, melting point, viscosity. Okay. So when there is a change in physical property because of the presence of what? The solute, the amount of solute, then there arises colligative property. Are you able to understand? So from this, you can have one important statement. Colligative property is dependent on what? The amount of substance, number of moles of substance. Or you can say colligative property depends on weight of the solute present in the system. Do you understand? So, similarly, we can explain depression of boiling, freezing point. Okay. Now let us move to depression of freezing point. Depression of freezing point, you have got ice. This ice, it is at 0 degree. That is, you know very well, water freezes at 0 degree. That you know. Now, when you add some salt, okay, some salt, what happens? This further decreases to minus, say about 1 degree or 3 degree, like that. Okay, so it means there is a drop in the freezing point. So this is indicated as delta TF, that is depression of freezing point. That is given by, that is originally it has some freezing point 0. Now the solution TF. Okay, so where T naught F is the freezing point of what? Water. Freezing point of water in pure state. Whereas TF is equal to freezing point at, freezing point of solution. Okay, so freezing point of solution means after adding the salt. Okay, so this is called depression in freezing point. So you should try to understand this one also. As I already mentioned, this also depends on what? The number of moles of the solute. Okay, number of moles of the solute. Clear? Right. Now let us move further. So colligative property, let us focus on elevation of boiling point and depression of freezing point. Okay, right. Elevation of boiling point, this delta TB is proportional to molality of the solution. Previously I would have told simply number of moles or weight of solute. Okay, so here more precisely delta TB is proportional to M. M means molality. Molality. Okay. And similarly, delta TF. Okay. So this is proportional to molality. The same. Okay. So in this case, you have to introduce a proportionality constant, and that is called Kb. It's known as molal elevation constant. Molal elevation constant. Or it's also called ebullioscopic constant. Okay. Ebullioscopic constant. So ebullioscopic constant means molal elevation constant. And similarly here you can introduce Kf here. So this is known as molal depression constant. Depression constant. Okay, so that can be represented by Kf, and this is also called cryoscopic constant. Okay, cryoscopic constant. Clear? Now, after introducing the uh, proportionality, it becomes equal, is it not? So, delta TB is equal to KB into M. Similarly, here delta TF is equal to KF into M. Okay, right. Now let us move further. Delta, we know already, molality is nothing but number of moles divided by weight of the solution. So since we consider dilute solution, okay, dilute solution compared to the weight of the solute, weight of the solvent is more. So in the denominator, this can be cancelled. So we know W is equal to W1 plus W2. So compared to the weight of a solvent, the weight of solute is very, very less, that is negligible. So you can say approximately W is equal to W1. So you can replace this. Therefore, M is equal to N2 divided by W1. So this W1 should be always mentioned as kg. Then what is the unit of molality? That is equal to, N2 means mole. So mole per kg. That's it. Mole per kg. Okay. Right. Now we need to further convert this. Say we already know N2 is equal to W2 by M2, where this 2 represents solute. Okay. 1 represents solvent. So that is the convention we adopt here. Therefore, N2 means I can put M is equal to, instead of N2, I can put M2 by W2 by M2 into 1 by W1. So this can be further converted into what? That is, suppose if W1 is given in gram, so it has to be converted into kg, is it not? Therefore, W2 divided by, still remember this is kg. Okay, so W2, so W2 is weight of the solute, is it not? Weight of solute. Okay, in gram. And M2, molar mass of the solute. Molar mass of solute. So this is given in gram per mole. Okay. And what about this W2 by M2? W2 by M2 into 1000 divided by, because we are going to convert this into kg. Kg to, gram to kg. So you can put W by 1000 reciprocated. So 1000 divided by W1. Now it is in gram. Please note down. Okay. So let us now include this in the final equation. We already know that is delta TB is equal to KB into M. Now we can replace this. So delta TB is equal to W2 divided by M2 into 1000 divided by W1 into, and this KB should come in front. Okay, so this is KB into, okay, so this is the final equation for elevation of boiling point. Do you understand? So what is KB? Elevation of boiling point constant, that is molar elevation constant, and this is not molar, LAL or ebullioscopic constant. Delta TB elevation of boiling point, W2 weight of the solute, M2 molar mass of the solute, and 1000 factor, then W1 weight of the solvent. You understand? Right. So similarly, you can explain the TF, delta TF. The same logic can be applied here. So delta TF is equal to KF. You know already M, which is nothing but W2 by M2 into 1000 divided by W1. Okay, the same logic can be applied. Do you understand? Right. And you should know the unit also. So let us derive the unit of KF. Unit of KF. So let us retain KF this side, and delta TF into M2, is it not, into W1 divided by, all this can be brought here, and W2 into 1000. So 1000 being a that is a factor, you can ignore it. Now delta TF. So delta TF, that is given in Kelvin. And what about molar mass? Mole, that is gram per mole. Molar mass is given as gram per mole. Okay. And what about this W1? That is given in kg. Remember, kg. Okay. Divided by, what is W2? W2 is gram. And 1000 we already converted. So gram can be cancelled. So Kelvin, mole inverse, and then kg. Are you able to understand? So the unit of cryoscopic constant Kf is equal to, that is Kelvin kg per mole. So this is the way you have to indicate. Okay. And similarly, the same unit can be derived for elevation of boiling point also. Do you understand? Right. So there is one more important thing we should note down. As we have already explained, that is delta TB elevation of boiling point, that is the colligative property. It is always dependent on the amount of solute, that we can prove. For instance, Kb here, it is constant. So Kb is constant. Okay. And what about molar mass? That is also constant. There is no change in that. So it is constant for the solute. And then you have taken the fixed quantity. So W1, that is constant. Okay. So the only variable here is W2. So you can put W2. So making constant into, all these are constant, into W2. It means, you know very well, delta TB is dependent on the amount of the solute present. So likewise, we can prove similarly for delta F also, that is dependent on W2. Okay. So this colligative property is applicable in case of, there are some conditions. It should be a dilute solution. You cannot take any concentrated solution. So dilute solution, very dilute solution, it is applicable. Second, non-electrolyte. It should not be an electrolyte. So non-electrolyte. It should be non-electrolyte. Electrolyte. Okay. Then non-reactive. You should not react with water. Okay. Non-reactive. So these are the important conditions. Okay.